Okay, so today I am going to discuss another session that is JAM 2025. This is NAT 2 marks question, numerical answer time. This is the 2 marks question, the second part of NAT. Okay, so let's start. Okay, so the first question says that is you have a NPN bipolar junction transistor which is connected in a common emitter configuration. This is the configuration also given. The amplifier is operating in the saturation regime, so it is operating in the saturation region, and it is given that the collector emitter saturation voltage is 0.2 volt. So VC is basically this voltage. VC is basically this voltage. So this voltage is 0.2 volt. The thing I want to mention that don't confuse with this language that collector emitter saturation voltage is 0.2 volt. So you may wonder why are they saying saturation voltage? They can simply say collector emitter voltage. But remember they had already mentioned that it is operating in the saturation region. So don't confuse with the language, okay? So and another thing is the current gain beta is 100, so the maximum value of base resistance, okay? So this is a straightforward problem basically. So you first apply KVL in this loop. So going in this way, okay, coming to ground. So 5 minus 3 into IC minus 0.2 is basically 0 because in this region there is no resistance. Okay, so IC is 4.8 by 3. Okay, so in units of milliampere, so it is 1.6 milliampere IC. So you can simply get IB is equal to IC by beta, that is 1.6 by 100 milliampere. Now apply KVL in this loop. Okay, so 1 volt minus IB into RB minus 0.68 is equal to 0. So RB is 1 minus 0.68 is simply 0.32, and IB is 1.6 milliampere, that is 1.6 into 10 to the power 3. So it answer will be 20. Okay, so the integer answer and it is 20. Okay, so this is the first one. The second one, okay, so for a Zener diode as shown in the circuit diagram below, the Zener voltage Vz is 3.7 volt. For a load resistance RL is equal to 1 kilo ohm, a current I1 flows through the load. If RL is decreased to 500 ohm, the current changes to I2. So you have to tell the ratio of I2 by I1. Okay. So you most of you may do a mistake, silly mistake here. So see, these two are parallel. Okay, so this voltage is 3.7 volt if it is operating. If it is in the operating region, it is operating, then it's this voltage is 3.7 volt. Okay, so the current is the this region will also have 3.7 volt. So you may do this mistake that in the first case I1 is 3.7 by 1 kilo ohm, and I2 in the second case is 3.7 by zero point 0.5 kilo ohm. The 500 ohm is zero point 0.5 kilo ohm. So simply you can take I2 by I1 is equal to 2. Okay, but you may do this mistake, but they are already mentioning two decimal places, then you can guess there is some kind of issue going here. Okay, so the obvious thing that should come to your mind that check this voltage at this node. If this voltage is greater than Vz, then this is in operating region, otherwise it is not operating region. This will disconnect it, this will disconnect it. It is like an open circuit. Okay, so let's first check for RL is equal to 1. So for RL is equal to 1, if there is no Zener diode, then the current flows in this fashion. Okay, so the current is physically 5, right? 5 ampere, 5 milliampere. Okay, so the voltage at this node is basically 5 volt. So 5 volt is definitely greater than 3.7, right? So it is operating in this case. So in this case, I1 is 3.7 milliampere. That is fine. But what happened when you reduce it to zero point 0.5 kilo? Let's check. So when this is zero point 0.5 kilo ohm, the current in this loop is basically your 10 volt divided by 1.5 kilo ohm. Okay, so 10 by 3 by 2, 20 by 3, so 6.67 milliampere kind of thing. Okay, so if you now calculate this voltage around this, so it will be less than this one, because 10 minus 1 into 6.67, it will be less than 3.7. Okay, so it should be if it is greater than 6.3, this 6.67. So 6.67 is greater than 6.3, so it will be less than 3.7. So it will behave like a disconnected circuit, a open circuit. Okay, so the current I2 will be simply 20 by 3 is equal to 6.67 milliampere. Okay, now you take the ratio, you will get approximately 1.80 kind of thing. Okay, so this will be your answer. Okay, up to 10 decimal. Let's do this quickly. 6.67 divided by 3.7, so 1.80 kind of thing. Okay, so this will be your answer. Okay, so 53. Okay, 53 is a good question. I mean good in the sense you have to do a little bit careful calculation. Okay, so 1 kg of water at 27 degrees Celsius, that is 300 Kelvin, is brought in contact with a heat reservoir at 370 degrees Celsius, that is 310 Kelvin. Upon reaching thermal equilibrium, the mass of water, I mean the same water, is brought in contact with another heat reservoir, that is 47 degrees Celsius, 320 Kelvin. The final temperature of water is 47 degrees Celsius. That is obvious, because if you connected something with a heat reservoir will don't have change temperature. Heat reservoir will like our theoretical fixed temperature object. Okay, so it is a very weak thing, and its temperature almost negligibly change. Okay, almost fixed. Okay, so which I am connecting to the heat reservoir, its final temperature will be in equilibrium with the heat reservoir. This is the concept. Okay, so the change in entropy of the whole system in the entire process will be up to 2 decimal place, and your specificity is given. So firstly, m is 1000 gram. I am converting into gram because the C is in 1 calorie per gram per Kelvin. That's why I'm converting into gram. Okay. So let's first process. For the first process, let us calculate the total entropy change. Okay. So mc dt by T, this is the entropy change of the water, plus what is the entropy change of this heat reservoir. See, heat reservoir will have fixed temperature. Its temperature will remain at 310 fixed. So the heat rejected, or sorry, the heat absorbed, if you heat rejected is plus, then heat absorbed is minus. You can change the plus and minus sign according to your convention. If you take heat rejected is plus, then heat absorbed is minus, or heat rejected is minus, absorbed is plus. So you can do minus here and plus here, it doesn't matter. So what is the total heat rejected by absorbed by the 1 kg of water, or rejected by the heat reservoir? Okay, so it is 1000 gram into 1 calorie. In change in temperature is 300 to 310. So it is 10 divided by its temperature. Okay, so minus 1000 log 310,230 plus 10 to the power 4 by 310. This is the first process. Okay. Now the second process is again similar kind of thing, just going from 310 to 320. So this will mass remain same. The temperature in the logarithm will change. It will become 320 to 310. And again, the change in temperature is 10 Kelvin or 10 degree Celsius. So again, it will be 10 to the power 4. But this time the denominator will have 320 Kelvin, because the heat of the temperature of the second reservoir is 320 Kelvin. So now add this to S1 plus S2, you will get your answer. So 1000 log 320 by 300, okay, plus 10 to the power 4 into if you add this to, I mean 1 by 1 310 into plus 1 by 320, you will get some kind of this. Now you have to do this, put these values in calculator carefully. I think this job is more difficult in finding the expression. Okay, so people often can do mistakes, so that's why it's a lengthy problem actually. So I was getting something around 1.03. Okay, there is a range probably. Okay, so yeah. Now this problem is easy actually. Okay, so this is a easy problem. So if this AF is vector given to you, and you have to say what is the value of the integral f dot dr over a circle of this. So this can simply be done with the Green's law, Green's theorem. Okay, so f dot dr is equal to simply del cross f ds. Okay, so you just have to take the cross product. Okay, so it will be del cross f, that means here only x and y component are there, so only k cap will survive. Okay, so so it you can consider is m dx plus n dy, right? M dx plus n dy, so it will be del n del x minus del m del y. The direction will be k hat, and the circle which is in xy plane x square plus ay square 1, it has also, if you rotate counterclockwise, then the area vector will also in k cap. Okay, so k cap will, and dot k cap is equal to 1, and the area will be simply pi r square. Okay, no, not pi r square at the moment, you have to integrate it, but let's see what is del n by del x minus del m by del y. Okay, so it will be del n by del x is equal to, there is only one x here and this is all y, so 1 minus cos y by pi and this is minus sin y, so minus minus become plus, and taking derivative of sin y is cos y, so cos y by pi, so it will simply become 1 by pi. So it is independent of r or x or y, so it will simply come out of the integral, and you have simply the ds, and ds is what, your pi r square. Pi r square by pi is simply r square, and what is r? R is 1, so your answer will be 1. So this is a simple problem, you should get 2 marks from here. Okay, again this is a simple problem, you should get 2 marks from here. Okay, so you have mentioned, you have mentioned that angular velocity omega is constant, that is theta dot, or what say, omega is equal to constant, it is 2, and your r is given as a function of time as like this. The radial component of acceleration vanishes for beta. So what is the radial component of acceleration? Just simply put the formula r double dot minus r theta dot square, right? So what is r double dot? Here is only e to the power 2 beta t, only is the t dependent part. So if you take 2 times derivative, so 2 beta and 2 beta, so 2 beta square into r minus r into theta dot square, that is equal to, should be 0. So simply 2 beta is equal to theta dot, so beta is equal to theta dot by 2, theta dot is equal to 2, so 2 by 2 is equal to 1, so this will be 1. Okay, 56. A planet rotates in an elliptical orbit with a star situated on of its focus. The distance from the center of the ellipse to any focus is half of the semi-major axis. So this language may bit confuse you. So you can pause the video and again read the language and give try yourself first. Then I will show you. Okay. So the ratio of speed of planet when it is at nearest perihelion to the star, the furthest aphelion in integer. Okay, so basically you have to know the diagram of ellipse first. Okay, so you should have clear knowledge about what is center, what is foci, and what is what. Okay, so this is the center. Okay, so this distance is a, so center to this perimeter a, and focus is somewhere here. So this distance is AE. Okay, so here to here distance will be A into 1 minus E, and this focus to this point distance is A into 1 plus E. This is called the aphelion and perihelion. So focus is somewhere here, and there is obviously another focus, you can consider this one. Okay, this is also fine. So they are saying the center of the ellipse to any foci. So center of ellipse to any foci, this is the distance is AE, is simply half of the semi major axis, so A by 2. So you're simply getting E is equal to 0.5. Now Vmax to Vmean. What is Vmax? Vmax at perihelion. So this had a simple formula. I am not going to derive that. You can derive it. It is a very famous formula actually. You can easily derive it by conservation of angular momentum at the perihelion and aphelion, and conservation of energy at the perihelion and aphelion. So conservation of energy had a very simple thing at perihelion and aphelion, because r dot will go to 0 at this perihelion and aphelion. So you can simply use those formulas and derive this. Okay, so I am not going to derive that, but this is a very famous formula. You should remember it. And V mean is equal to root under GA by A, 1 minus E by 1 plus E. So this ratio will be 1 plus E by 1 minus E. Okay, so it is 1.5 by zero point 0.5, that is equal to 3. So this will be 3. Okay, so you should get 2 marks from here. This is, I consider this is a easy problem. Okay. 57 I have also little bit confusion, so I am not. If someone do this problem, then please give the solution in comment. You can suggest me what should be the solution in comment section. Okay. 58, this is good problem, and I guess most of the students can't even do it because this is rare problem. And this problem is actually, if you want to know the theory, the best theory is from B Ghosh book, Basudev Ghosh, B Ghosh book, and the book name is A Textbook on Light. I read this book in my BSc courses, and this concept is very well explained there. Okay, so a textbook on light. Okay, so textbook on light, B Ghosh, Basudev Ghosh. This concept is very well. Okay, so normally we consider this kind of parallel film, the light enters, light goes, and this. So we can consider the total path difference, that is we calculate 2 mu t is equal to 2m plus m. For normal incidence, this is true. If it not normal incidence, then 2 mu d cos r, where I is the angle of incidence, r is the angle of refraction, is equal to 2m plus 1 lambda by 2. We most of you don't know this. Most of you just only know this for normal incidence. Some of you advanced students may know this, but this the wedge shaped case maybe maximum students don't know. So it has a very small angle alpha, so it is not parallel film. Okay, so for this kind of problem, your problem reduces to 2 mu t cos r minus alpha, or alpha minus r, what can you say, it is inside the cosine, is 2m plus 1 lambda by 2. And if you want the how it goes to derive, you must have to follow what is the derivation there. B goes a textbook online. Okay, so I am not going to focus on that, but let's do solve this problem first. So mu is given, and normal incidence means I is equal to 0, r is equal to 0, so goes to 0. So your formula reduces to 2 mu t cos alpha is 2m plus 1 lambda by 2, right? So let me erase this because I don't think I uh, extra page, sorry for that. Okay, so yeah, 2 mu t cos alpha. Now alpha is very small. You can also see it in given options. It is of the order of 10 to the power minus 5. So weight set field normally alpha is very small. Okay, so this term also goes to 1. Okay, approximately, because alpha is very small. Now what is t? So this is some thickness. This is the thickness you are telling T. But it is varying, right? Like here we have a thickness T1, here we have another thickness T2, here we have another thickness T3. And for each thickness they are giving interference patterns. Okay. So if you consider this distance some D1, D2, D3, then you can see if alpha is very small, then tan alpha is approximately is equal to alpha, right? So T is approximately is equal to alpha time this D. D means I am now telling this distance as T. Okay. So 2 mu alpha D is equal to 2m plus 1 lambda by 2. Now suppose this is alpha is fixed, mu is fixed. Suppose this is D1, where you are getting some m is equal to the mth order maxima. Suppose, and 2 mu alpha, suppose D2, you are getting the m plus 1th order, that means 2m plus 3 lambda by 2. So what is your difference? 2 mu alpha delta D, or say delta x, is equal to lambda. So your delta x is equal to lambda by 2 mu alpha. This is your delta x. Now what is the information given in here? Let's see. The film is illuminated by monochromatic light of wavelength 600 nanometer wavelength is given. 10 interference fringes per semi are observed. So 10 fringes in one semi. So what is the fringe width of one fringe? One fringe has how many width? That is 1 by 10 semi, right? So your delta x simply 0.1 semi. This is given. Okay, this is given in disguise. Actually, the language may be a bit confusing, but this is given in disguise that delta x is equal to 0.1 semi. Okay, so if you now solve this, the alpha is now 2 lambda by 2 mu delta x. Delta x is given, mu is given, 2 is given, 2 is there, lambda is 600. So you can simply find it will be 24 into 10 to the power minus 5. So the answer will be 24. Okay, so this is, I think, very advanced problem. Okay. uh, 59. 59 is an easy problem, you can solve it. Okay, and orthorhombic crystal lattice constant is this. So a b c are this, the distance d101 between successive planes. Okay, so you basically have to directly apply the formula h square by a square plus k square by b square plus l square by c square to the power half. So now apply it. So 1 by uh, a square, 3 square is 9 plus 0 plus 1 by 16. 4 square is 16 to the power half. So it will be 4 into 3 by 5, 12 by 5, that is equal to your 2.4, I guess. Okay, right? 12 by 5, 5 to, yes. Consider a chamber of room temperature 27 degrees Celsius filled with a gas having molecular diameter 0.35 nanometer. The pressure in Pascal to which the chamber needs to evacuate it so that the molecules have a mean free path of 1 kilometer, and you have to give your answer 10 to the power minus 5 order. Okay, so this is again a direct formula based question. Okay, so lambda is root under 2 pi, uh, pi is not in root under 2 pi sigma square n. N is the number density and n is what? N is p by kt. So root 2 pi sigma is given molecular diameter 0.35 nanometer. 0.35 into 10 to the power 9 square p. K is value is given. T is 300 Kelvin, 27 degrees Celsius, 300 Kelvin. So P is basically 300 K by root under 2 into pi into this sigma square, and lambda is 10 to the power 3 meter. 1 kilometer is 10 to the power 3 meter. So I am getting it as 0.76 into 10 to the power minus 5. So according to me, this is 0.76. Okay. So if you don't, sometimes some books don't take this root 2 in account. This is a very fine correction actually. So if you don't take this root 2, your answer will be slightly greater. But I think the range should be in such a range that you should match it. Okay. So according to me, this is 0.76, I guess. Okay, so the problem 57 I am not able to get up, I mean, very good. I am a bit confused. Okay, I am not sure because of this angle. Maybe I have forgot this polarization part a little bit. Okay, so if you somebody match this and somebody get a right solution, then please comment. Okay, so yeah, thank you, and I will eventually upload the part 1 and MCQ and MSQ all the solutions today. Okay, so yeah.